Hello and welcome to Victory Online Academy. This is Igcse physics session, and in this session we are going to learn about current electricity, and we'll be focusing more on series and parallel circuits. This is very important topic with respect to IGCSE exam, and lot of questions IGCSE ask based on series and parallel circuits. Let's discuss them. Okay, so current electricity we are going to learn. Okay, so first quickly I'll explain you the basis of circuit is Ohm's law. So if V is the voltage, if V is the voltage of a cell or the battery, and R is the resistance across it, so V, the voltage applied over here, that will be directly proportional to the current flowing in the circuit. So if you place an ammeter here, and if you keep on increasing the voltage, the current will keep on increasing. So V is directly proportional to I. This is the Ohm's law. Voltage is directly proportional to the current, or the current flowing in the circuit is directly proportional to the voltage or potential difference applied. So if you remove this proportional sign, you will get R. So V is equal to IR, or V is equal to RI. R is the constant of proportionality, or also called resistance in the circuit. The important thing to note here that the resistance does not depend on the voltage or the current. If R is equal to V over I, it doesn't mean that if you increase the voltage, resistance increases. It doesn't happen like that. If you increase the voltage, current will also increase so that it remains constant. Current resistance actually depends on other factors. The factors depending resistance are the length. The first factor is length. So resistance is directly proportional to length. If you increase the length of the wire, resistance of the wire or the conductor increases. So it's directly proportional. Second is resist area. Most importantly, cross-sectional area. Cross-sectional area. Cross-sectional area means this particular area, this one, the circular area, cross-sectional area. So here resistance is inversely proportional to area. More the cross-sectional area, lesser will be the lesser will be the resistance. Okay, and lesser the cross-sectional area, more the resistance. Third factor is temperature. So if we increase the temperature in the metal, if we increase the temperature, resistance increases. Why the resistance increases in the metal if you increase the temperature? Because resistance happens due to the collision of the electrons which are flowing from one end to the other end, right? So when we increase the temperature, collision starts increasing, collision increases, and that's why resistance increases in the metal. But in semiconductors, if you increase the temperature, resistance decreases, because over there is a band theory which is associated with it. So semiconductors like germanium and silicon, the resistance decreases with increase of temperature. But in case of metals, if you increase the temperature, resistance increases because the collision in the electrons increases. Okay, so in case of metal, resistance will increase if temperature increases. So they are directly proportional. So if you combine them, resistance proportional to length and the area, so you can write it like this: resistance is directly proportional to length and inversely proportional to area. If you remove the sign, proportionality sign, you will get rho L over A, where rho is RA over L. This rho is called resistivity of the conductor. Resistivity of the conductor. Okay, so resistivity it is fixed for a particular kind of metal, like for steel, or for copper wire. For copper wire, whether you take 10-meter copper wire or 1,000-meter copper wire, resistivity will remain the same, because resistivity depends on the nature of the conductor. So that's fixed for the type of metal wire we are using, the type of the conductor we are using. Okay, so that's constant for a particular metal wire. Resistance, this is very important formula, rho L over A. Okay, now we are going to discuss series and parallel connections. So series circuits. So series circuits, like if the resistance are connected in, if two resistors are connected in series like this. So let's take R1 and R2 are two resistors which are connected in series. So how we'll figure it out whether the connection is a series connection or the parallel connection. So in series connection, see, whatever the current which is starting from going out of the battery, that same current flows from R1 and the same current flows from R2. So current remains same across all the resistors which are connected in series. So current remains same across all resistors. So it means if you place an ammeter here or a place an ammeter here, A1 and A2 both ammeter will show the same current. Okay, so ammeter you can place it anywhere in the series circuit. That ammeter will show the same value because current is the same across the circuit. The only thing which divides is the voltage, because as the current is remains the same, they have the different resistance, and we know V is equal to IR. So different resistance means different voltage. So different voltage drop you will find across R1 and R2. So if V1 is the voltage across R1 and V2 is the voltage across R2. So what is the relation between V1 and how we can use V1 and V2 to find out the equivalent resistance? That's what we are going to discuss. So V1 and V2 will be different because V is equal to IR, I is the same, but R is different. That's why V will be different. So V1 and V2 will be different. And voltage, if V is the voltage being supplied by the battery, so this V has to be equal to V1 plus V2, right? Because the voltage is nothing but the energy supplied per coulomb of charge. So if voltage is 10 volt, it means 10 joule of energy is being supplied to 1 coulomb of charge. Okay, so it's like energy. So whatever the energy is being supplied by this battery, the energy will be lost across R1 and R2. So V has to be equal to V1 plus V2 because energy, there is no loss of energy. We are considering that there is no other loss in the energy, or there is no other loss in the voltage, or there is no internal resistance. Okay, so this V has to be equal to V1 plus V2. Now in place of these two, R1 and R2, if you want to replace it by a single resistance, if you want to replace it by a single resistance RS, which will do the same work what R1 R2 doing together combinedly in this circuit. So what will be the value of RS? That's what we are going to figure it out. Okay, so if they are doing the same thing, if RS is doing the same thing what R1 and R2 doing combinedly together, so if I is the current flowing here, I will be the current flowing in this circuit as well. Okay, RS is the equivalent resistance of R1 and R2. So V is equal to V1 plus V2. We can write this V from this circuit as IRS, right? V is equal to IRS. V is equal to IR. And this is IRS. V1 when we can write, because I is the current, R1 is the resistance, we can write IR1. V2 we can write as IR2. So IRS is equal to IR1 plus R2. Now II gets cancelled out, and RS, the equivalent resistance in series, is R1 plus R2. So if you want to find out the equivalent resistance series, so you just need to add both the resistances. If this is 3 ohm and this is 2 ohm, so the equivalent resistance will be 3 plus 2, 5 ohm. Okay, that's the series connection. And parallel, let's discuss parallel connection, parallel circuits. Okay, let's discuss the parallel circuits. So sorry for the disturbance. So let's say this is R1 resistance and this is R2 resistance. Okay, and V is the, so V is the voltage being supplied by the battery, R1 and R2 are the resistances, and let's say I is the current which is coming out of the battery. And see what happens here, that the current gets divided. Okay, so current gets divided in parallel connections, but the voltage remains same. So voltage remains same, current gets divided. If we want to find out the equivalent resistance of R1 and R2, if we want to find out the equivalent resistance of R1 and R2, so the concept we will use here, if I is the current which is coming out of the battery and I1 and I2 it's getting divided into I1 and I2, so I has to be equal to I1 plus I2. Okay, and from here we can write I as V over Rp, because V is equal to IR, so I is equal to V over Rp. So V over Rp, which is Rp is the equivalent resistance in parallel, I1 is V over R1 and I2 is V over R2, because voltage is going to remain the same. So here the voltage is V and here also V, because voltage remains same. So V you can take common, so 1 over Rp is equal to V 1 over R1 plus 1 over R2. So VV gets cancelled out and you will get R 1 over Rp as 1 over R1 plus 1 over R2. So Rp from here will be, if you want to find out the value of Rp, that will be R1. If you take the LCM and simplify this, you will get Rp as R1 R2 over R1 plus R2. Take the LCM and then make Rp in the numerator. So you'll get R1 R2 over R1 plus R2. Let's solve some questions. So two resistors are connected in parallel. These two resistors are connected in parallel. The current through the top resistor is 2 ampere. So 2 ampere is the current flowing. What is the reading of the ammeter? So we need to find out the reading of the ammeter. For that, we need to find out the current which is flowing through 5 ohm. And if we are able to find out that current, we can add both of them, because that ammeter current is getting divided into two sections. So how we can find out the current over here? So that we can write 2 into 10 the voltage, because voltage across here and voltage across here is the same. So 2 into 10, this is V is equal to IR. I into R equals to again I into R. So voltage is the same. So we got I as 20 divided by 5, which is 4. So 4 is the current over here. 4 plus 2, 6. So 6 is the answer. Because here is the 4, here is 2. So add them. So 6 is the answer. Next is the diagram shows two resistors connected in series with the battery. What is the current through the battery? So current which is coming out of the battery, these two are in series. So total resistance will be 15, 10 plus 5, 15, and current is 10 over 15. So 10 over 15, that's like 2 over 3, which is 0.67. So that's why the answer is C. Next, a 10 ohm and 30 ohm resistor connected in series as shown in the diagram below, making the potential divider circuit. Potential divider means it divides the voltage. Potential means the voltage. It divides the voltage. So we need to find out what would be the reading of the voltmeter. So what is the voltage? Whatever the voltage across 10 ohm, that will be the reading of the voltmeter. Okay. So to find out the reading of the voltmeter, as these two are in series, we will find out the current first. So current, to find out the current, we need to find out the equivalent resistance. So equivalent resistance is 30 plus 10 is 40. So equivalent resistance is 40 and current is voltage divided by resistance 10 over 40. So which will give you 1 over 5, which is 0.2 ampere. So 0.2 ampere is the current, and we need to find out the V is equal to IR. So 10 into V is equal to IR. So I is 0.2 multiply resistance is 10. So we'll get 2. So that's why the reading will be 2 volt. Okay, very simple. Let's solve another question. A student sets up the circuit below. It contains 4 fuses and 4 bulbs. She finds that none of the bulbs are lit, but only one of the fuses has blown. Which fuse has blown? So fuse fuse helps to make the electrical appliances safer. So they actually allows the flow of current. So if A, B, C, D is, this is A, B, C, D are the fuses. So if they will get fused, if they are not working, so the current will not flow through them. Okay. So if we think that A is not functional, so the current can flow from here, right? So this bulb will light up and others can also light up. Because only one fuse is not working. If you remove this fuse C, so current can flow from here. If you remove D, the current can flow from this side. So if you want to stop the current to flow, this fuse should not work. If this fuse is not working, the current will not be able to complete its path. So that's why current will not flow. It's not that the current will flow till here and then stop. The current only flows when the circuit is complete. So if this B is not working, then the circuit is not complete and the no bulb will work. So that's why B is the answer. Next question. The current, which of the following statements about the current in ammeter XYZ is correct? So X, Y, Z. There are three ammeters. The current through X is equal to the current through Y and current through Z. Wrong, because the current which is coming out, the current which is coming out of the battery is Z, and the same current it should be going through in the battery. So the Z and the X current should be equal. So the current through X is equal to the current in Z. That's the answer. Because whatever the current is coming out of the battery, the same current goes into the battery. Next, a student connects together some identical resistors in three different combinations. Which of the answers below shows the correct order of the combinations from the lowest resistors to the highest? So we know that series has the highest resistance and parallel has the lowest resistance. So P will be the highest resistance, this will be the lowest one, and then the in the middle is R. So so it is asking from lowest to the highest. So lowest is Q, then R, and then P. So Q, R, P. That's the answer C. Next, a bookshop owner sets up the circuit below, but they find out the lamp is too dim. What change can be made to the circuit to increase the brightness of the bulb? So brightness depends on the voltage. So if the voltage increases, the brightness will increase. So putting putting another resistor in parallel with the battery. So if you put another resistor here, will this affect? See, volt, it should affect the voltage, okay, across this. So if you put uh, another resistance here, will it is it going to um, affect the resistance of the resistance, overall resistance? See, right now the voltage is being shared between these two. Okay, so if you put a like putting a resistor over here across the battery is the same as putting a resistor here. See, it is not affecting the voltage of this, right? So this will not work putting a resistance in parallel with the bulb. So yeah, if you put a resistance over here, so the equivalent resistance will decrease, and if the equivalent resistance decreases, then the voltage decreases, so that will also not work. Putting another resistor in series with the resistor, yeah, so if you put another resistor in series with this resistor, so the voltage, the equivalent resistance across this will decrease, and if the equivalent resistance decreases, the voltage across this will also decrease. If the voltage across this decreases, automatically the voltage across the bulb will increases, so more brightness. That's why the C is the answer. Not in series, the answer is D, parallel. It should be in parallel. So because if you put in parallel, the resistance, equivalent resistance across the resistor will decrease, and if the equivalent resistance decreases, voltage decreases, because they are in this bulb, and this combination is in series. So if the voltage decreases, the voltage will across the bulb will automatically increase. That's why D is the answer. A teacher writes a set of notes about two non-identical bulbs which are connected in parallel. Which he makes one mistake. Which of the following is incorrect? So parallel combination is there. They have the same current flowing through them. In the parallel connections, the current is not the same. The voltage is the same. That's why this is wrong. The other should be right. They have the same potential difference. That's correct because the voltage is the same. They can be switched on and off individually. Exactly, because if one is off, the other can be on. One bulb is not affecting the other bulb. Our connections at home, that is in parallel, because if you switch off the TV, that is not affecting the refrigerator or AC or the bulb, so they can be switched on and off individually. That's right. If one bulb blows, the other will continue to work. Exactly. If one is not working, the other can work. So this all three are right. Option A is wrong because it says same current. Same current is there in series, not in parallel. Yeah. So we are done with the questions. If you have any doubt in any concept, you can ask me in the comments. Okay. Let me revise everything quickly. So what we have learnt is we have started with Ohm's law. V is directly proportional to I. The current flowing in the circuit is directly proportional to the voltage applied. So more you apply the voltage, more current will flow. And V is equal to R. R is the constant, and R is the resistance of the wire. So R is equal to V by I. But it does not depend on voltage or the current. Resistance does not depend on voltage and current. Resistance is a constant. It depends on the length, area, and the temperature and the material. So length is directly proportional to length, it's inversely proportional to area. So if you increase the area, resistance decreases. If you increase the length, resistance increases. Temperature, if you increase the temperature of the metal wire, resistance increases. But in semiconductors like germanium and silicon, resistance decreases if you increase the temperature. Resistance is rho L over A. Rho is the resistivity of the conductor, because resistance also depends on the material of the wire. Okay, so like um, silver has is the best conductor. So silver has less resistivity than copper. Okay, series circuit. Then in the series circuit, the current remains the same, voltage gets divided, and we found out that resistance in series, the equivalent resistance is given by R1 plus R2. That's what we derived here. And parallel circuits, voltage remains same, current gets divided, and RP is R1 R2 over R1 plus R2. Here is we did the questions. Yeah, based on these questions are the same, and the concept, if you'll apply, you'll be able to solve any question. So I hope you have learned something in this session, and so thanks for watching. And if you have any doubt in any subject, if you're struggling with any subject, you can register for free demo session on our website. We have expert teachers working with us. We have helped thousands of students in excelling the performance in the class. So do register on our website. Our website is www.victoryonlineacademy.com. Thanks for watching. Goodbye.